Oh, we're looking at the stream. Oh, this is not okay. Uh, I'm sorry. Hold on a second. Let me bring up what actually needs to be brought up. Hey, there we go. What do we think of this new like angle here? First of all, I can see I have a monitor over here, so I can see the stream. So I need to stop like looking at myself. Um, I made a huge mistake. I made a huge mistake. I went back. I realized I had not put the stream details in. It's bugging me having the thing over here. Let me just scoot y'all. We're going. I think we might go back over here. Well, no. Troubleshooting on the fly. How's that? It's not horrible. It's not horrible. Um. Yeah, this could work. How am I? Yeah, this could work. Um. Oh. I realized that yesterday I usually go in after the stream and put finish up the title and put a new verse in the description, stuff like that. Add to the description like what we looked at in the video, and I realized to try and title the video, I went back and to see what it was called, the video that we were looking at yesterday, and I realized you could not hear me. You couldn't hear me. I was like, oh no. And I went back, and it was like, ugh. It was like a week's worth of streams. We should be good now. I can see myself metering. I should just stick and check though, bro. I just can't. It's so frustrating. I'm like, something must have. I had everything set up the way that I wanted it to, and so I just didn't worry about it. I assumed it was all working, but something happened to where it made my microphone not work. My microphone's fine, but according to OBS, it wasn't working. Um, and so here we are. Man. So I apologize for that. You live and learn. But yeah, how's this new angle? I'm trying to what's it like? I'm curious, right? What is it like if it's up here? Nah. Cuz right now you guys are kind of angled. You're kind of lower than my like eye line, you know what I mean? And so it's got to kind of look like I'm like, cuz right here it I'm looking up into like the belly of the the belly, the like the main part of the screen, and it like works, I think. But because I'm going to be trying to do more gaming videos, intentional sort of like YouTube stuff, and I might try and put. I think I might try and put my face somewhere around here. We'll see. We'll see. The reason I say that is because I mean, it's kind of just not at all related to programming, but like, once I, streaming like this is recording it as well, and some like there's going to be one clip with this baked into the footage, which is not ideal, and so I want to be able to like record something on a better camera, which I have, and have that be my webcam, face cam, and then just that over this webcam, because this is just a webcam. This is a webcam, but if I could just put it over this, it'd be like the same dimensions pretty much, but it would just look better. So, anyway, I digress. I've been rambling for about 5 minutes, but we're gonna round out this. Man, I just can't believe it's been a week of streams that you guys couldn't hear, but like, this week has been just a week of one-offs. If you couldn't tell by the length. So, yeah. We're going to wrap up this week with just, another one-off. And next week, we may do more. I don't know. I don't want to promise anything, but let's just get into this video.
So now we have a socket.
All right. Application protocol. It kills me. You guys couldn't hear because I've been stopping it and reading it through per usual, but y'all couldn't hear me. I'm so sorry. Application protocol. Since TCP and Python, I'm just making sure my mic is working. Since TCP and Python gives us a reliable socket, what do we want to do with the socket? What problem do we want to solve? Application protocols, mail, World Wide Web. What problem do we want to solve? So are these like the only two things you can do basically when it comes to sockets and whatnot, ports and all that? Stack connections, application, transport, internet link. He was talking about this yesterday.
Socket, we are going to talk about what we're going to do with it, right? So the socket basically functions at this level. Your application is saying, make me a socket, which is sort of this endpoint, and then the connect actually connects to an application on the far side. And there's a port involved, so that might be port 80. And this is the far host, and that could be www.py4e.org or data.py4e.org. Okay, and so the socket is solving this, and the question then is, what are we going to send and what are we going to expect to get back? And that's what we call the application protocol. So we know that these two have made a phone call. And it's no different than making the phone call and saying, hello, right? And
HTTP hypertext transfer protocol. Hypertext transfer. Okay. The dominant application layer protocol on the internet. Invented for the web to retrieve HTML, images, documents, etc. Extended to be data in addition to documents, RSS, web services, etc. Basic concept, make a connection. Oh, basic concept is make a connection, request a document, retrieve the document, close the connection.
Everyone knows that when the phone rings and you pick it up, you're supposed to say hello. And that's part of our protocol. So who talks first, right? So the dominant protocol that we use on this, phone rings and you pick a call and saying, hello, right? And everyone knows that when the phone rings and you pick it up, you're supposed to say hello. And that's part of our protocol. So who talks first, right? So the dominant protocol that we use on in this section is the HTTP protocol. The key is hypertext transfer protocol. It's dominant. It's really easy to use. That's why I use it as an example. But realize that there are many others like mail and file transfer and remote login and all kinds of other protocols. Each is a different application protocol. They all use sort of sockets at their lower level. But then on top of that, they layer the rules of the road for retrieving hypertext web pages. And
the hypertext transfer protocol is a set of rules to allow browsers to retrieve web documents from servers all over the internet, or from servers over the internet.
We have used, on top of that, they layer the rules of the road for retrieving hypertext web pages. And we have used the
to allow browsers to retrieve web documents from servers over the internet. I was just trying to make sure that I understood that correctly, because over, like over, or over meaning like widespread. You know what I mean? I think it's like over the internet, from servers over the internet. To retrieve web documents from servers over the internet. Yeah, I think that's right.
These for all kinds of other things. So the protocol, like I said, is like who answers the phone layer, the rules of the road for retrieving. It's a different application protocol. They all use sort of sockets at their lower level, but then on top of that, they layer the rules of the road for retrieving hypertext web pages. And we have used these for all kinds of other things. So the protocol, like I said, is like...
What is a protocol? A set of rules that all parties follow so we can predict each other's behavior and not bump into each other on two-way roads in USA. Drive on the right side or right-hand side of the road on two-way roads in the UK. Drive on the left-hand side of the road.
Who answers the phone first? What do they say? What happens if the person doesn't answer right? Can you hear me now? Those kinds of things. And it's a real simple thing. And all you really need to do is, so that both sides can agree, you have to write a thing that's like the rules in the middle and say, okay, everybody, as long as we all do this, we'll be fine. It's as simple as picking on which side of the road the cars can drive on. It works fine no matter which side. But if each car randomly picked, it would be really kind of a mess. So if you look at the typical URL, and this is
HTTP protocol, that's right there. Oh, so that's like the rules, right? Host, document. Okay.
Is one of the things that the web innovators in 1980 really well, and this is one of the... If you look at the typical URL, and this is one of the things that the web innovators in 1980 really invented that was wonderful, and it seems second nature today, but in 1990 it was rather revolutionary, in that these uniform resource locators included in themselves a protocol, the host to connect to, and the document to retrieve. So this is one of the clever ideas that the web came up with, because we used to have to pick a program like FTP or Telnet or whatever, SMTP, then we had to go to the right host, and then we had to talk to that host a certain way. So in HTTP, we had to go to the or whatever, like FTP or Telnet or whatever, SMTP, then we had to go to the right host, and then we had to talk to that host a certain way. So in HTTP,
go to the right host. Okay.
Then we had to go to the right host, and then we had to talk to that host a certain way.
Getting data from the server. Each time the user clicks on an anchor tag with an href equals value to switch. Href. Every time the user clicks on an anchor tag with an href. Href to value, or href equals value to switch. Okay, hold on, I think I got it. Each time the user clicks on an anchor tag with an href equals value to switch to a new page, the browser makes a connection to the web server and issues a GET request to get the content of the page at the specified URL. The server returns the HTML document to the browser, which formats and displays the documents to the user. Which I think this right here is where HTML comes in. I think. Oh, duh. I read that as HTTP. It registered as HTTP. The protocol, uh, transport protocol, the stuff we're just learning about. I read the HTTP, so I'm sorry. It ran in front of my face the whole time.
So in HTTP, it's a really simple protocol invented in 1989 and 1990 by Tim Berners-Lee and Robert Caillou at CERN, and they created a protocol that we have grown to know and love and use for way more than retrieving documents, as we'll see in the upcoming chapters. So we're going to talk a little bit about what happens when you click on a page that has a link. Now, there's all kind of fancy stuff that can go on, but this is the basics. And so let's just imagine for the moment you are sitting looking at a web page, drchuck.com/page1, and inside that there is a hyperlink. It is a indication that says when you clicked on this page, go to a different page. And in that you see the name of the page that you're supposed to go to. So we click on this link.
You mean the name of the page that you're supposed to go to?
Page that you're supposed to go to. And in that you see the name of the page. See at a web page, drchuck.com/page1, and inside that there is a hyperlink. It is a indication that says when you clicked on this page, go to a different page. And in that you see the name of the page. See indication that says when you clicked on this page, go to a different page. And in that you see the name of the page that you're supposed to go to. So we click on this link, and that is a browser. This is an application. This is a process or an app that's running on your computer. This is the browser, okay? And when the browser sees the click inside your computer, then the browser makes a connection to port 80 on the web server, drchuck.com, and sends the request. This request that it sends is precisely specified by a standard, which we will see in a second. Then the web server does some magic work.
So it shoots it up to the server. That does the get thing.
Is precisely specified by a standard. Web server, drchuck.com, and sends the request. This request that it sends is precisely specified by a standard, which we will see in a second. Then the web server does some magic work.
Is this HTML? I think it is.
Oops, let's go back. Then the web server does some magic work in here, reads some files, runs some code, does whatever, constructs an answer to our phone call, and sends it back. And it sends, in this case, back a web page in the format of HTML, the hypertext markup language, which is different than HTTP, which is the protocol that we're exchanging. HTML is the format of the document we're getting back. And in this has an anchor tag, href, and the end of anchor tag, and some highlighted text. And now your browser gets this back and then renders it according to the rules of HTML and CSS and JavaScript, etc., parses it, and then makes a pretty web page. And this web page happens to have a link back to the first page, and if you click there, it will do this over and over and over again. And that is the request response cycle. And that's governed by a series of internet standards. These are
Internet standards are standards for all the internet protocols, inner workings. Standards for all of the internet protocols and inner workings are developed by an organization. Internet Engineering Task Force. You know, that was a thing. Standards are called RFCs, request for commands. The Internet Protocol treats each internet datagram as an independent entity unrelated to any other internet datagram. Time to live. Header checksum.
are standards that were built from the 60s, 70s, 80s, and 90s and continue to this day by a group called the Internet Engineering Task Force, or IETF. The documents they produce are called RFCs, which stands for Request for Comments. The RFC, the word RFC is
Did I say commands? I'm so sorry. I'm off the ball. I'm sorry. Comments, not commands.
kind of like a sort of joke, as it were. They're trying to be kind of funny in that funny is not the right word. It's ironic in that they're trying to say even some of the protocols of the internet that we've used for several decades, they're always interested in improvements, and that's what the RFC stands for, and they're all named RFC dash whatever. And so now we have named RFC of the internet that we've used for several decades. They're always interested in improvements, and that's what the RFC stands for, and they're all named RFC dash whatever. And if we were going to cruise around, we could find some various RFCs, and this is RFC 2616. It might have been revised since then, but this is like a document, and this is what they look like. Hypertext Transfer Protocol version 1. And so you're reading this document. You're going to write a browser, and you want to talk to the application protocol that is HTTP. This is Hypertext Transfer Protocol version 1. And so you're reading this document. You're going to write a browser, and you want to talk to the application protocol that is Hypertext Transfer Protocol version 1. And so you're reading this document. You're going to write a browser, and you want to talk to the application protocol that is HTTP. This is one of many documents that helps define what HTTP is. Version 1. And so you're reading this document. You're going to write a browser, and you want to talk to the application protocol that is HTTP. This is one of many documents that helps define what HTTP is. So if you look down and said, oh, here's what a request looks like. This
A request message from a client to a server includes within the first line of that message the method to be applied to the resource, the identifier of the resource, and the protocol version in use. Request equals request line, general header, request line. The request line begins with a method token, followed by the request URI and the protocol version, and ending with CRLF. The elements are separated by SP characters. No CR or LF is allowed except in the final CRLF sequence. Request line, method SP, request URI, SP, HTTP.
This is how I'm going to get a document from the server. And you keep reading and you keep reading, and it says,
making an HTTP request, connect to the server like request document or document. Get. Am I supposed to do this?
You're supposed to have the request method with a space, with the request URI, the request method with a space, with the URI with a space, the HTTP version, and the carriage return the line feed. That's what it's saying. And so it looks kind of like this, right? We say get the document followed by a space. There's got to be one space. You do two spaces, and it's going to be quite frustrating, okay? And so spaces, that's what it's saying. And so it looks kind of like this, right? We say get the document followed by a space. There's got to be one space. You do two spaces.
Document.
And it's going to be quite frustrating, okay?
That's the document, right? So that's not the what?
And so it looks kind of like this, right? We say get the document followed by a space. There's got to be one space. You do two spaces, and it's going to be quite frustrating, okay? And so this is an example.
Holy smokes. Telnet 80. Trying. I'm guessing that's an IP address connected to escape characters. The caret. Get that. Okay. Date. Connection close. Text. The first page, if you'd like, you can switch to the blah, 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 second page, and it has the URL for the site. Oh, interesting.
Example that you can.
Why is this like boom, boom, boom? I don't know why it's coming back at us.
Run on a number of frustrating, okay? And so this is an example that you can run on a number of on Linux operating systems and Macintosh operating systems with no changes. If you install Telnet on your Windows box, you should be able to run something like this as well.
Wait, what? Telnet?
So Telnet is a program that...
Okay, one second here. Can I? What? I don't know about this. Okay.
That we used in the old days. It used to be how we logged into servers, but because it doesn't encrypt your data back and forth, we don't use it anymore. But it basically is a program that can open a socket to a host on a port. And I'm saying telnet to this host on port 80. And at this point, I am connected. And whatever I type on my keyboard is going to be... And I'm saying telnet. It basically is a program that we used in the old days. It used to be how we logged into servers, but because it doesn't encrypt your data back and forth, we don't use it anymore. But it basically is a program that can open a socket to a host on a port. And I'm saying telnet to this host on port 80. And at this point, I am connected. And whatever I type on my keyboard is going to be sent to that server. Now, if you're doing this, you probably want to cut and paste this really fast, because if you take too long, most web servers will be like, you're a human. I don't want to talk to humans. I want to talk to programs. So remember to type this fast enough.
What?
And then you have to hit enter twice. So you have to have a blank line here. Just type this exactly as it's shown, and then you will get back the server. If you do it right, the server, and the server is properly configured, the server will give you back some headers. And this is metadata about the document you're going to get. For example, it's saying it's got text/HTML, which means that the remaining stuff is going to be in HTML, hypertext markup language. It has a blank line, and then the actual document, and then the connection is closed. And so if you do this, you can set this up in a way that you can run this on your own computer and in effect hack through the back door a web server. Now you can't hack the secure web servers.
Accurate hacking in movies? Now this is interesting. Matrix Reloaded, Born Ultimatum, Die Hard 4.
And mail servers used to be easy to hack, but they're harder to hack now because they challenge you for information. But part of the reason I'm so obsessed with the command line is this is how real hackers work, and they know how to talk some of these protocols more directly. And so we think of this beautiful, sophisticated application talking to some other thing, and it's all pretty, and we got wonderful clicky buttons and nice usability. But the reality is, like in the Matrix Reloaded here, the kinds of things that really talented hackers are doing use command lines, and they really know what's going on, and that's how they do it. They understand what's going on better than the developers of the computers that are trying to be resistant to the hacking. So I come from a long line of using the command line, and that's why I encourage you to use the command line in this course.
Command line? Let's write a web browser, bro?
Kinds of things that really talented hackers are doing use command line, the computers that are trying to be resistant to the hacking. So I come from a long line of using the command line, and that's why I encourage you to use the command line in this course.
Does that just mean the command prompt? The command line?
Things that really, and it's all line, is this is how real hackers are harder to hack now because they challenge you. So obsessed with the command line is this is
command line
inside your computer back a web page in the format that, and that is and 90s and continue to this for, and this is RFC 20. This down said, oh, and the carriage return the line feed. So I come from a, instead of typing you to use the command line in this course. So the next thing we're going to do is we're going to go up into the application layer, and instead of typing those commands by hand, we're going to actually send them from Python and write a very simple Python web browser.
Whoa. This is going to be crazy. What type of HTTP request is usually used to access a website? GET. Yes. Okay. Hold on. What is a command line? A command line interface is a means of interacting with a computer program by inputting lines of text, called command lines. Okay. Nope, sorry, you can see my other screen. There we go. So command lines are lines of text. Excuse me, goodness. Now let's look up telnet. Kind of worried to do this. Here, let me try and download this real quick. Okay. I'm installing it now. Computing space requirements, bro. I have a space. Waiting on the wizard. There we go. I think I heard some animal like outside. I need a registration key. Look at this. Hold on. Look at this. So I went here. What? Okay. So I don't have that. I didn't know it was something you had to buy. I'm not gonna buy it. I'm not gonna buy it. All right. Well, that is going to do it for today. Yeah. Thank you for watching and listening to today's stream. I'm so sorry for the past like stinking what is it like 6? Oh my goodness, 6 streams. I'm so sorry, but thank you for watching this one. Probably won't be streaming tomorrow, but on like streaming programming tomorrow, Monday, technically early Tuesdays, probably when we'll get back to it. But you all have a great weekend. Love God, love people, and I will see you guys soon.